on Friday, we talked about conjectures. And conjectures are statements that are based on patterns. We are doing some pattern recognition, and we are going to try to anticipate or predict what is going to happen next. And one of our last examples, our next to last example, on page 2, we were looking at gas prices, and we had to write a conjecture about whether we thought the gas prices were going to continue to increase or continue to decrease. What did we think was going to happen? Well, conjectures, if they're not always true, then we say those conjectures are false. I want to get that written down up at the top, right next to where it says counterexamples. If a conjecture is not always true, then it is false. If a conjecture is not always true, then we say it is false. If a conjecture is true for all cases, it is an always true, then we have to do something called proving it, which we are going to learn how to do later this week. To show that it's not always true, it takes only one example that contradicts to show that it is not always true. And we call that example a counterexample. And that's what we're going to practice doing on a couple examples here. Only one example where it is false. That's enough to make the whole thing false. So let's look at example number 9, part A. Our statement, our conjecture, is if n is a real number, then negative n is a negative number. So we are starting off knowing that this is false. To show that this is false, I want this to be true. But this part false. All right, so I have to think up a real number, but when I put a negative sign in front of that real number, I don't end up with a negative number. So let's look at an example here. And before we look at any other examples, when it says real number, my best guess is that every number you have ever heard of is a real number. In Algebra 2, they talk about a concept called imaginary numbers. So if you haven't had Algebra 2 yet, you've never heard of the concept of imaginary numbers before. Even if you have had Algebra 2, if imaginary numbers doesn't sound familiar, then every number you've ever heard of is a real number. Decimals, fractions, positive numbers, negative numbers, everything you've learned is a real number. So let's try a little thought experiment here. Why don't we let n equal -4? This is a real number. So I got this part to be true. Then -n would be -4. Because I'm taking this right here, -4, and putting it in the place of the n with the negative sign out in front. Well, what happens when you have a negative and a negative together like this? It becomes a positive. So -n would then be a +4. This is not a negative number. So I made the first part of the sentence true. I picked out something that really was a real number. And then I showed that that didn't mean that the second part of the sentence had to be true, because I found an example where it wasn't true. So to put this into a sentence here, -4 is a real number. But -4 is not a negative number. So that would be my counterexample. My counterexample would be -4. A counterexample can be a number, it can be a drawing, or it can be a sentence. So for part A, it would have been enough for me to show that I picked out a real number, -4, and that when I take it and put a negative sign in front of the number that I chose, I did not get a negative number back. Do you think that's the only counterexample I could have for this one? No. What about if I let n be 0? What happens if I do a negative and then a 0? Does that give me a negative number? No, that just gives me 0. 0 is not positive or negative. It's kind of neutral. It's in between the positive and negative numbers. So that could also be used for a counterexample. Let's look at part B. It says if angle ABC is congruent to angle DBE, then angle ABC and DBE are vertical angles. And we want to think up a counterexample. So we're starting off already with the idea that this is false. So I want to think up an example where this is true. But I want the back part to be false. Let me find a good color here. Is it possible that I have angles that are the same size as each other, but they're not vertical angles? Yeah, so I'm going to draw an example where I see that. What kind of a shape do you have to have for vertical angles? You have to have an X. So if I have something like this, these would be vertical angles. This angle is congruent to this angle. But what about if I had an angle like this? Could I have another angle that looks just like it that it doesn't touch? Yes. So one of these I'm going to call angle ABC. Let's say, oh, I don't know, let's pretend that that's 40 degrees. And then angle DBE is also 40 degrees. So here's my counterexample. The first part is true. My angles really are congruent. But the second part is not true. They are not vertical angles. I could even take them and give them the same point B. Let's see if I can put these together to make that true. Yes. So I could do this. This is my point B. They share a point B, but they are not vertical angles because I don't have that X. Let's look at another one here. Part C says if n is a real number, then 1 over n is less than n. So I want this part to be true. I have to pick out a real number. But I want this back part false. So I need to think of some examples here. I'm going to work with a number line as I try to think this through. Let's see if 0 is right here on my number line. Let's pick out a number. Picking out a real number. What about if I let n be 3? If n is 3, then 1 over n would be 1 over 3. Where would 1/3 be on this number line? Between 1 and 2 is where 1/3 would be? Between 0 and 1. So 1/3 would be, I don't know, about here-ish, right? Is 1/3 less than, smaller than 3? Is it to the left on the number line? Yes. So that's not going to work as a counterexample because this is true. 1/3 is less than 3. I need a number so that when I do 1 over the number that I choose, I don't get something that is less than. 1, let's try 1. All right. Let n equal 1. Then 1 over n would be 1 over 1. What is 1 over 1? 1. So 1 over 1 is equal to 1. not 1 over 1 is less than 1. I found an example that'll work here. So this right here would be my counterexample. If n is 1, then I can do 1 over my chosen number, and I do not get something that is less than my original number. Absolutely works. We could do the same thing with -1. Or I could do -3. -3, let's look at this. Let n equal -3. Then 1 over n would be 1 over -3. -3 would be right here, but -1 over 3 would be over here. -3 is less than -1/3. -1/3 is actually greater than -3. -3 is farther to the left, so it is the less than thing. So this would also work as a counterexample. So there is more than one right answer. I just have to find one spot that makes the first part of my sentence true, but the second part of my sentence false. All right, let's look at one last example like this, and then we're going to talk about conditional statements. If a line intersects a segment at its midpoint, then the line is perpendicular. So a line intersecting at the midpoint, I want this to be true. The line is perpendicular to the segment. I want this to not be true. What does perpendicular mean? What's perpendicular? Makes a right angle. So if I have a line segment like this, got my endpoints. Midpoint could be right here so that these two segments are the same size. And I need a line that intersects that, kind of like this. Does that blue line go through the segment at the midpoint? Yes, so the first part of my sentence is true. Is that blue line making a right angle with the black segment? No. So this would be a counterexample. This shows that my statement is not always true. The blue line intersects the black segment at the midpoint. But it's not perpendicular. Right. The homework that's due for tomorrow, you need to work on conjectures and predicting the next one in the pattern. And then there's a couple of the problems where you were asked to come up with counterexamples for things that are false. So that's what you're going to use these examples to help you do. The rest of what we're going to talk about for our class time today is going to be things that will be on the next homework that you guys will get tomorrow. But we're going to go ahead and push forward into that material. So we're going to look at statements, conditionals, and biconditionals. So let's just start off with this idea of a statement. A statement is any sentence that is either true or false, but not both. The truth value is the truth or falsity of the statement. And we often represent statements using letters such as P or Q. So I'll have a sentence that I call sentence P, or a sentence that I call sentence Q. If I have a statement represented by P, then not P is the negation, has the opposite meaning. And we use this squiggle right here in front of the name of our statement to mean not. So an example here. I am 33 could be a statement. And then not P would be I am not 33. Or I could have a statement. I'm going to call this statement R. My favorite color is not yellow. If that's what my statement is, what statement would have the opposite meaning from that? My favorite color is yellow. So in this case, not R would take away my not. That would be my favorite color is yellow. So when I'm thinking about negations, if the sentence, the statement doesn't have a not in it, and I want to negate it, I put not in. If the statement already has not, and I want to negate it, I take the not out. And then we have compound statements. There are two kinds of compound statements that we're going to look at. One is called a conjunction. A conjunction is where we put two sentences together with the word and. This is true only when both statements are true. So for and, this is true when both are true. And we have this symbol right here that kind of looks like a capital letter A, but just missing that middle bar. Kind of looks like a mountain peak. That is our symbol for and. The other kind of compound statement we have is called a disjunction. This is when we put a sentence together, two statements together with the word or. This is true if at least one statement is true. So only one has to be true. And the symbol that we have for a disjunction looks like a capital letter V. So a capital letter V in between two statements means or. Let's practice. So we're going to flip over to page number 4. We're going to write a compound statement for each of the conjunctions that are described. And then we're going to find the truth value. We're going to determine whether or not that statement, the compound statement, is true or false. So for part A, I want statement P. That's this statement right here. The figure is a trapezoid. And I want statement R. This statement down here. The figure has 4 right angles. And we're going to put that together with the word and. So I would say the figure is a trapezoid. And the figure, or it, has 4 right angles. I can repeat the subject of my sentence again instead of saying it, or I can use it, referring to the subject of my sentence here. Because this is an and, both must be true. Is this figure a trapezoid? No, what is that figure? It's a square. So this is false. It's not a trapezoid. Does it have 4 right angles? Yes, this part is true. So when I put those two parts together into one statement with and in the middle, is this whole statement put together true or false? False. Both parts have to be true for an and statement to be true. So this statement is false. Now we get into our notation here. What does the squiggle in front of this P mean? Not necessarily not true, it just means not. I'm going to take my statement and I'm going to negate it. So if P is the figure is a trapezoid, not P would be the figure is not a trapezoid. So that's going to be the beginning of my sentence here. And then what does this symbol right here mean? Careful. It's like a mountaintop or a capital letter A. This is our and symbol. So we're going to put these two statements together with and in the middle. So I want not P. So the figure is not a trapezoid. And what is statement Q? The figure has 4 congruent sides. So I can write that after my and. The figure has 4 congruent sides. Or I can say it. It has 4 congruent sides. Because it says and, I need both to be true. Let's look at the two parts of my sentence. The figure is not a trapezoid. Is that true or false? That is true. It is not a trapezoid. It is a square. What about the second part of the sentence? Does it have 4 congruent sides? Yes, that is true also. So is my compound statement true or false? It is true. Let's try one more like this. Let's look at number 2. We want to use these statements, P, Q, and R, to write a compound statement for the disjunction. And then they show it to me like this. What does this symbol mean right here? That capital letter V. That means or. And what does the squiggle in front of the R mean? It means not. So let's go look at statement R. Here's statement R. So not R would be that segment AB is not congruent to segment BD. So I want statement P, this one right here, and I want not R. So my compound statement, my disjunction, angle A, B, C, and angle C, B, D are complementary or segment AB is not congruent to segment BD. How many things have to be true for my or to be true? Only one must be true. Let's see. ABC and CBD are complementary. What does complementary mean again? Add up to 90 degrees. Something plus something equals 90 degrees. Is that true about these two angles? Do these two angles add up to 90? No. So this is false. Together they make a straight line. They're a linear pair. These two are supplementary. What about the second part of the sentence? Segment AB, this segment right here, is not congruent to segment BD, this segment right here. That is false because they really are congruent. Which means that my compound statement, my disjunction, is false. Okay, so compound statement is like a compound sentence in English. It means that we're taking two sentences and putting them together. That's what a compound statement is. We have two different ways of doing that. I can either take two sentences and put them together with the word and. In that case, we call it a conjunction or an and statement. A disjunction is where I take two sentences and I put them together with the word or. So if I put them together with and, it's a conjunction. If I put them together with or, it's a disjunction. So another example of something that would be a conjunction would be, my favorite color is yellow and I have brown hair. I've taken my two sentences and put them together with and they both have to be true in order for the whole statement to be true. Or I could take something together, like put it together and make it an or. I could say, you can either come to my after-school office hours on Monday or on Wednesday. And in that case, if only one of them is true, then the whole statement is true. Let's talk about something called a conditional statement now. A conditional statement is an if-then statement. If something, then something else. If P, then Q. A conditional statement is made up of two parts. It's made up of a hypothesis. This is the part that comes right after the word if. So in this example over here, if it rains is my hypothesis. Or it can be an implied if. And then we have the conclusion. The conclusion is the part that immediately follows the word then. So in this example over here, then the parade will be canceled. The parade will be canceled will be my conclusion. Or it could be an implied then. These are cause and effect sentences, if-then statements. When I say it might be implied, what I mean is, like today after school, I already know I'm going to go home and my daughter's going to ask me if she can play Minecraft when she gets off the bus. And I'm going to tell her, make your bed and you can play Minecraft. I didn't use the words if and then, but they're implied. If you go make your bed, then you can play Minecraft. So sometimes we don't hear the words, but I could say the sentence with if and then in it, and it would still make sense. I would like to practice identifying some hypotheses and some conclusions. We're going to do that on page 5, number 3. We're going to skip the top part of the page for right now, and we're going to look at number 3. Number 3, part A. If a polygon has 6 sides, then it is a hexagon. Everything after if, up until my comma, is my hypothesis. So a polygon has 6 sides is my hypothesis. After the word then is my conclusion, and I only have one problem with this. If I walk up to somebody and I say, it is a hexagon, they're going to say, what's it? What is the subject of this sentence? If a polygon has 6 sides, then it is a hexagon. What do they mean by it? The polygon, yes. So my conclusion would be a polygon is a hexagon. All right. Let's look at part B. Another performance will be scheduled if the first one is sold out. Do you see our keyword of if? Is it at the beginning of the sentence like last time? No. But everything after if is my hypothesis. It says the first one is sold out. The first one what? The first performance. So that's my hypothesis. The first performance is sold out. What will happen if the first performance is sold out? Another performance will be scheduled would be the conclusion. What is the hypothesis in part C? The forecast is rain. What would the conclusion be then? I will take an umbrella. All right, last one, part D. A number is divisible by 10 if its last digit is a 0. What is my hypothesis? If the number's last digit is 0, yes. So a number's last digit is 0. What's the conclusion? Yes, a number is divisible by 10. What's due tomorrow? Homework is due tomorrow. First homework, number 1. You're going to do conjectures and counterexamples and predictions. If you need another copy of the homework, very bottom paper in this red organizer, it's the bottom white paper. You can grab that. So you need to practice writing conjectures, which are predictions about what's going to happen next or what is the pattern that you have seen. You're going to practice making those predictions, what comes next, and you're going to practice writing counterexamples. Give me one example where it's false. Have a great rest of your day, guys. I'll see you tomorrow.